So to name the interval, we're going to call this a one sample Z interval for proportions. And you want to have all of that in there. You want to say it's one sample, you want to identify it as a Z interval, and you want to say it's for proportions. You need all three of those things to get full points for your naming the interval. And then always don't forget to define your parameter. I always try to tell you guys when it's one of those things that people miss often. This is probably the most commonly missed thing on confidence intervals, is defining the parameter. It's something you guys have done since the beginning of this class, yet you forget it whenever it comes in here. It's not that you don't know how to do it, you just forget to write it down. On a hypothesis test, we have to write out the hypothesis using the parameter, so it's kind of a reminder, oh yeah, I need to say what that means. You don't have to do that here. So it's an easy thing to forget, but it will cost you points. So don't forget to write it. Okay? For means, instead of categorical, we're looking at quantitative data. So our interval name will be a one sample T interval for means. And again, don't forget to define your parameter. So very similar to what we did with hypothesis testing, only we don't have a hypothesis. We still name what we're doing. We still define the parameter. We just don't write out HO and HA. Now let's look over at check the conditions. So our conditions are very much like what we did for hypothesis testing. And I'll tell you, there's only one slight difference. Everything else is the same. So our general conditions, we want good quality data. So we want either a random sample or a random assignment, or we want them to tell us it's representative of the population. If they say this sample is representative of the population, that meets this condition. Okay, so you'll see one of those on your practice problems where it says it that way. So, good quality sample, and then a large enough sample. So here, for the first one, for a good quality sample, we want to think about randomization. So either a random sample or a random assignment. And for checking sample size, what do we need for proportions on sample size? You guys remember?
NP greater than 10.
Right. Right. We want both NP and NQ greater than or equal to 10. So we want at least 10 successes and failures. But this is the one I told you there was one condition that was slightly different, and this is the one that's a little bit different. Because since we don't know what to expect, because we don't have a population proportion, that's what we're trying to estimate. If we knew it, we wouldn't be doing this. So we don't know what to expect. We use the sample. So if we were trying to find the proportion of students who are left-handed, well, we would have, well, this many people are left-handed in our sample and this many people are not. So we use the numbers from the sample to check this sample size. And you want to make sure you show the numbers. You can't just say NP is greater than 10. Okay, well, what is NP? Give me a value. Okay, so you want NP greater than or equal to 10 and N times 1 minus P greater than or equal to 10. And again, since we don't know P, you're looking at your sample to see how many fit the condition we're looking for and how many do not. Then for means, randomization. Same thing, random sample or random assignment, same as the other one. And then for sample size, this one, we just need one of the following to happen. So we have 3 different ways we can meet this condition. It only has to meet one. Okay? Can somebody tell me one of the ways we can meet the sample size condition? Yeah. So it could be normality as stated. Joe, what was the one you were saying?
Central limit theorem.
Central limit theorem. So what do we need for that to apply?
Sample needs to be greater than or equal to 30.
There you go. So we have N greater than or equal to 30. CLT applies. And when you're using this, you need to show what your sample size is and write this out. So if your sample size is 40, you would say 40 greater than or equal to 30, CLT applies. You need that full statement. Don't just write part of it. You can't just say CLT applies without any justification of why it applies. And you can't just say this without saying I'm using the CLT. So you need both parts. Okay? You may remember the other one? There you go. If you're given data, you will graph it and then show that it's approximately normal. So questions on any of those? This should be pretty familiar stuff because we just did similar conditions before. Okay, so you should have in your folder a page like this. And so we're going to do the 4 practice problems over just those first 2. So I'm going to give these out. After you finish, just trade with another group until you've done all 4. Pay attention to the problem number you're working on. First of all, keep writing them in the order on their page instead of the order of the problem numbers. both of those numbers you give me.
So 32. So are we doing like 32 divided by 153 and then using that percent times just like if you're okay, so just so we just okay, 32 greater than 40. Okay.
That's how I'm Okay, let me interrupt you guys for just a second. So if you're still working, that's fine. You can finish it after we do this part. So some groups are finishing. I want to go ahead and do this part so you can start on the back side. So do the math, the formulas. So the general form, this is what's on the formula sheet. So let me show you what it looks like so you'll know how to identify it. So this is the point estimate. So that's going to be either p hat or x bar, depending on if you're doing means or proportion. So it's the value from your sample. Excuse me, from your sample. So that's where we start, and then we do plus or minus the critical value multiplied by the standard error. So point estimate, value from the sample that was calculated. Critical value, that's going to be from the table. And then this is your standard deviation or standard error. So on the formula sheet, it's right above these formulas here on the inside. So your confidence interval is your statistic, so the value from the sample, times critical value, and then standard deviation. So that's how it's written, because your standard deviation is going to depend on if it's means or proportions. So you're just going to take whichever standard deviation you need and plug it in. Critical value comes from the formula sheet, and then your statistic comes from the sample. So all of those are right there. You just need to be able to plug it in. So to make this more specific, for proportions, what this is going to look like is p hat, so the proportion from our sample, plus or minus, and since we're using a z interval for proportions, we get the z value from the table. So we usually see it with an asterisk, meaning this is the critical value from the table. So when you see z with an asterisk, that's what it means. You're looking it up on the table as a critical value. And then our standard deviation for proportions is just that same formula we've been using. We just use the p hat instead of p because we don't know the value for the population. That's what we're trying to estimate. So the z with an asterisk is our critical value. So the way we use this is we do the infinity line on the t table. And I'll show you what that means. Right. Let me explain that whenever I show you what we're doing. So, if you remember, on the t table, when we're dealing with t, we need to know degrees of freedom. So on the t distribution, we have all these degrees of freedom. What happens is, as we get bigger and bigger and bigger values, these values down here at infinity are the normal distribution values. These are equal to the z-scores for those same values of alpha. So that's why we go to infinity, and then these are the same numbers. If we look them up on the z-table, we would get these values. So instead of having to find them in the z-table, they're right here at the bottom of this one, so it's easier to find. So that's why we go to the t-table and use this bottom line where the infinity is. I don't know if you guys can see it. So see down there at the bottom it says infinity? That's the ones you'll use. So if we're doing a 95% confidence interval, that's our critical value. If we're doing a 90%, 1.645. So you can see they're right above those numbers, so it's easy to find. Okay. And then the rest of it you should be able to get from the problem and just plug it in. On the calculator, so calculator steps to get here. You'll do stats, of course. And then go over to tests. And then we'll go down to one prop z int. And that gives us the one proportion z interval. For means, what you're going to do is our point estimate is now x bar. We'll do plus or minus our critical value. Now this is going to be from our t table. And our standard deviation will be s over square root of n. So now t asterisk is the critical value. And you'll use the degrees of freedom is n minus 1. So your sample size minus 1, that's the degrees of freedom line we will look at. Now, if your value is not on there, so I'm going to let you write that down. I'll show you what I mean. So when you're looking at degrees of freedom on here, you'll notice it counts by ones all the way until we get to 30, and then it goes 30, 40, 50, 60, 80, 100, 1000. So it skips over some values when you get big. Okay? If you had a sample size of, let's say, 47, well, your degrees of freedom is 46. We would think round up, but you always go down. Okay? On these, if it's in between, you pick the smaller one. Okay? So anytime it's between there, you go smaller. If your sample size were really, really big, let's say like 9,000, you would just use the infinity line. So most of the time, you're going to have something up here where you're going to find the exact value. But occasionally, you'll see one with like 50-something or 40-something. Okay, so on the calculator, we'll do, of course, stats and then test. And then we'll go down and pick up t interval. So on this part over here, we went over this on block day on Tuesday, so I'm not going to go back over it. What I would say, make a note. These two things here are the ones that we use most often. So I highly recommend what in the world am I writing